welcome back and welcome to 2026. This will not be the first video on my channel that comes out this year, but this is the first that I'm filming specifically knowing that it'll come out in the new year. So I hope you had a really wonderful Christmas holiday break and that you have the right amount of energy to take it to 2026 with you. I know it's going to be a really big year, very exciting. If you are new to my channel, I know there's a lot of new people. My name is Harriet Farlow. I often say I missed the boat in computer hacking, so now I hack AI instead. What does hacking AI mean in practice? 3 years ago, I was working in the Australian government. I saw that AI security was taken really seriously there. As someone who's done a PhD in machine learning security, I wanted to take that same level of gravity and share it with the rest of the community, essentially. So I created my company, Maleba Security Labs, in 2023. And since then, I've done a bunch of work with different clients all around the world, educating and building AI security frameworks. So it all started with this channel. And I continue to share free content here as much as I can. So if you are new, please subscribe if you haven't already. Leave any comments, ask any questions you like. I do my best to reply in a reasonable time frame. But today we're going to be talking about two things that always come up in the AI security space, but tend to have a lot of fog around exactly what they are and how they work. And those are MCP and A2A. What are they exactly? So if you imagine this is more in an agentic AI context. So there's all these organizations now, all these businesses who are creating AI agents. So these are these more autonomous AI systems that can plan by themselves, they can learn about the world, they can make decisions within bounded contexts. But there's all these different kinds of researchers and companies creating them, and they can write their agentic AI code however they like. However, the important thing about AI agents, and really the only reason that people care about them and want to use them, is because of their agency, their agenticness. And a really important part of that is the ability to learn from and actually interact with the rest of the world, the digital world. So that means that agents need to have some way of interacting with that digital world. How do they learn about and communicate with other software tools, with other programs, with other applications, with the internet? But also, now that we have all of these different kinds of agents, how do they interact with other agents? Well, why would they want to interact? If you imagine that even an AI agent learning about its digital environment in some way is some kind of action, because there needs to be some kind of call and response in order to get a piece of feedback. The way that would have been done historically is by custom code. So you can imagine that if I'm some researcher who's created an AI agent and I want it to be able to, integrate it with Slack for some reason. Maybe it's doing some sort of internet research and then sharing it with a Slack group. I would write some custom code that integrates with the Slack API and sends and receives specific information and different, commands about when and how it can pop a message into a Slack channel. But I might write that code very differently to how some other AI researcher or developer might choose to write that code. And that means that there's inconsistent ways in how different agents are interacting with tools, but especially if we want those agents to interact with each other, there's not going to be standard formats or standard call and response structures that those agents will necessarily use by default. So, in answer to that problem, these two protocols were created. The first one is MCP. So this specifically fills the gap of having agents communicate with other tools. So what do I mean when I say tools? I mean specifically things like tools, applications, APIs. If you imagine an agent integrating with email, calendar, databases, tools like Slack, Jira. That's an example of a use case for MCP. A2A, on the other hand, is specifically filling the gap when it comes to agents communicating with each other. So that's a core difference, and it's quite fundamental. MCP was created by Anthropic in November 2024. It is open source, and in fact recently, as in sort of December 2025, it was donated to the Linux Foundation, and the Linux Foundation maintains lots of different open source projects, so that's a good candidate to release it to. It stands for Model Context Protocol. So if you imagine MCP being about models, agents talking to tools, I guess that's a way of giving them context, right? Especially if you think about that in terms of them, learning about their environment. So that's why it's called MCP. A2A was developed by Google and launched in April 2025. And there are other competing frameworks, protocols. We don't need to get too much into those sorts of definitions now. But I would say that these are two that tend to come up quite a lot, but don't think that this means that they are the definitive methods for having agents communicate with other protocols and agents. So A2A stands for agent to agent, so naturally it's about agents communicating. Both of these frameworks have been adopted because the organizations that created them are pretty big, and so they obviously were able to share and rely on a pretty big consortium of other interested AI related parties. So even though there are competing ones out there, quite a lot of other big organizations have then sort of come around MCP and A2A and just sort of use them as the default. The reason that I mentioned the difference between, what you would define a protocol is because if we think about a really famous, more popular example, I guess, of a very mature protocol, then we immediately think of the protocol that enables information transfer on the internet, and that is TCP/IP. So that's Transmission Control Protocol, Internet Protocol. So that basically, the term protocol means exactly that. It's a predefined way, or mechanism of that call and response. So it specifically defines for each of those transfers of information, like what kind of information you expect to see, what additional metadata needs to come along with that information. The reason that people don't always say that something like MCP or A2A are protocols in the same way is that something like TCP/IP is very mature. It's quite low level, so it's a lot closer to like the hardware layer. MCP and A2A are at the application layer, and right now they're still emerging. They're not nearly as robust, which is especially important when it comes to security and probably why you may have heard of them. But you can consider them a very early form of what TCP/IP would have been at the beginning. From a conceptual framework, technologically, they're obviously a bit different. But the reason that they're important is because if we didn't have them, we wouldn't have any framework. So in a security context, MCP, and I would say in particular because it's probably integrated a bit more often already, people tend to be using agents to interact with tools a bit more right now as a generalization than using agents to communicate with each other. So MCP comes up in a security context quite a lot, and people love to bash on it, but look, it's early. There's a lot of research being done on it and a lot of ways that people have been able to break it. That's part of the emergence of these protocols. The thing that I think is really essential is that any researcher, any developer, any organization who is thinking of relying on MCP or A2A need to keep in mind that there are so many security holes. It is a research first sort of framework. So I think it's wonderful to be experimenting and using them. But, you just need to keep in mind that in terms of building your organization's infrastructure around them, you might want to think about what that means from a security context first. So before we launch properly into security, it might make a bit more sense to explain exactly how they work. So MCP essentially defines a common language between a host, so that's the AI app or IDE using the model, as well as the client, which forms the user requests, and then a server, which actually talks to the tool or database and returns the results. So it works over standard channels like HTTP, for example. Another good example of a protocol. HTTP is the protocol that determines communication across the World Wide Web. So the internet infrastructure being different from the World Wide Web and how information and websites communicate. HTTP stands for Hypertext Transfer Protocol, and that is defining how web browsers communicate with each other. So MCP utilizes channels like that as well. Similarly, A to A uses a standard file, often written in JSON, which is a kind of language that also is used for HTTP, or relying on HTTP, which basically defines what an agent is. So its capabilities, its contact details, or at least how another agent could ping it, and then how other agents can send it structured requests. So also, on JSON over HTTP. If you're not super familiar with those kinds of terms, not super important. Basically, the point of saying things like JSON and HTTP is to say that is very similar to how, say, data is transferred over the World Wide Web. So not super different, at least in terms of that core layer. I'm going to head over to my laptop and I'm going to walk you through some more technical examples of exactly how this works. Okay, I'm jumping on to share my screen to show you something just a little bit more technical. So I do have a couple of MCP and A2A demos for my course, but they're not shareable quite yet. So let me know if you're interested in seeing some more interactive demos like that. But I wanted to show you some of the better resources that I've found on the web. The first one for MCP is Microsoft. This is their MCP for Beginners resource pack on GitHub. It's really pretty good. As you can see from the left here, there's a lot of information. So depending on where you're at, it might be a little bit too technical, but the good thing about it is that it does include some higher level information first before getting into the weeds. They also have these videos with April Gittins. I haven't watched them, but I love a video, so I'm not complaining. They go through a bit of an explanation that's maybe more professional sounding than mine, about how it works. They have some diagrams like this. So again, like I said before, if you imagine those key components I talked about, if you're agent, you have your host, your server, your data sources back over here. This is where MCP sits, and this is all within your your computer system. So you might have a few protocols that are working for different tools, for example. So you wouldn't have it working for everything. It would sit in between each of those individual arrows here. What I mean to say by that is that it's not like you would have one single MCP block sitting in the middle here. MCP facilitates each of those individual interactions between these components here. And the point they're making here with this is that you still, of course, have other things like web APIs that will get information for you from the internet before coming back into your computer and then using those MCP protocols. So it goes through those key parts of the ecosystem, like the hosts, the clients, and the servers, goes through how they work. I'm just going to drop down here to show you some of the different code it has here. So there's some code examples for the key components. I'm going to show you the Python code because I know most of you are probably used to working in Python. It's certainly what I'm more used to working in. But if you're more familiar with other languages, they have it here too. So they have this Python example building an MCP server. They have a library called fast MCP that you can install to utilize that as well. And then as you can see, so this is the server specifically, remember, there's those three parts of the ecosystem. But to create that server, it's really not a whole lot of code, right? You're creating the server here, the tool, and then this is an alternative approach that they're showing using a class. I won't go through the code here because that might be a little bit too much, but I mean, if you think of all the different ways of creating something in code, they're just showing you some of those examples. I also want to show you here the security section they have, because from a security perspective, this is really cool. It's a nice, I guess, compendium of best practices. They have a bit of theory. They have a bit of the sort of the landscape and what's happening. They have some examples. Where am I heading down? What I want to show you is these diagrams down here. So they have different scenarios and how that works, and a diagram always helps. They also have links to other sources. I recommend you check them out. Simon Willison has a lot of good research. I met him once, which is really cool. He was very nice, actually. So here you can see that you have an example of a prompt injection, but specifically in an MCP context. So you're going from your user, prompt an agent to do something. It gets metadata from the tool using the MCP server, context from a web page, returns that content. There might be some sort of prompt injection in there. And then there's this sort of guidance given back to the agent that is incorrect. I'm sure you can sort of understand how that might work. The interesting thing that I always say with MCP is that a lot of the more theoretical adversarial attacks that work because you're adding sort of manipulations to data might not be that realistic when you're thinking about the kinds of more traditional machine learning models and environments that organizations tend to use in production, not just in research. But with MCP, it means that it removes some of the human validation. It puts more trust in the model to be able to recognize threats or interpret instructions. I think that a lot of the more theoretical adversarial attacks become a lot more relevant when you're thinking about MCP and A2A. So anyway, continue looking through there. Check out the code if you want to give it a go. If you would like a tutorial specifically on the code, let me know. It's always a little hard for me to figure out exactly what kind of content you want, but let me know. The other example I want to show you quickly is about A to A. So this is from, I think this is specifically from Google. This is the source. This is, if you go to a2a/protocol.org, and I'll share a link as well. But they have all of this information, mostly in Python, about how to build an A to A agent. So like I said, it's a bit more about sharing specifics about, say, like the capability of different models. You can install these different packages that they provide that make it easier for you to not have to create all of that scaffolding yourself. And then they define an agent skill. So, like I said, that capability or function the agent can perform. It includes things like ID, name, description, tags, examples, input modes, output modes. And then, yeah, you can check things like the agent executor. This is it down here. It's not a whole lot of code. It's really just understanding exactly what it means. And then again, you have to make sure that you start the server. So follow through the code here. There's other good blogs and examples if you're looking for specific examples. I'll link a few more below. But these are some really good places to start. Now I'm going to link all of those resources below. So that was the Microsoft MCP for Beginners and then the A2A resource material on Google's website. Those are both really good starting points. I've seen quite a few blogs on this topic as well, but nothing that goes really technical. My course, the AI Security Fundamentals course, does do technical labs devoted to using MCP and A2A and thinking about how they work in practice. So comment below if you are interested or have any other specific questions, and I can give you a little bit of a demo of some of those as well. So now that you've seen a little bit about how MCP and A2A work under the hood, and I talked through sort of what that means from a weakness or vulnerability context, but let's tie it together by really thinking about what that means for AI security. So one of the main reasons that we tend to see these frameworks come up so much is because the nature of how they work, being quite emergent, being fairly lightweight, being at the application layer, means that, given the entire surface area of potential tools and agents that these frameworks help your system communicate with, that's obviously a really massive attack surface. And the reason that we're consistently seeing CVEs related to MCP is not just because it's, emergent and researchers are still finding vulnerabilities, edge cases, weaknesses, but because of the way that those frameworks are architected, they can't necessarily incorporate every security decision that you need to make when it comes to thinking about your agent security into those frameworks themselves. So when you think about some of the core issues or challenges related to how AI agents, consider security related aspects like access and authentication, permissions, which tools they can access, under what circumstances, how you think about your trust boundaries, which of your human users can interact with those AI agents, and then consider all of the AI specific things like how they're probabilistic, how you can't always guarantee the same outcomes or decisions in an agentic case given the same inputs or instructions. If you think about, I hope you watched the episode with Greg, CEO of Good Ancestors, because I found that really interesting. He's a very knowledgeable, great person to chat with, but the example that he gave where he created an agent that went to different websites to scrape policies, and then when it encountered a block, it basically found an illegal workaround and was able to get to those policy sites. Those are the sorts of challenges that previous frameworks just haven't had to deal with, and not always suited to deal with either. A lot of those technical or governance decisions wouldn't necessarily be in the MCP or A2A framework. So a lot of the time when we see security challenges, it's because those decisions haven't been made at other layers. And, where there are specific vulnerabilities related to, the MCP or A2A frameworks, it's often because it's not just the fact that there's like a vulnerability in the code, because the MCP and A2A code, there's not that much of it. A lot of the time it's because there's this improper amount of thought around how they're integrated within the rest of the system, specifically in a security context. So that's important to keep in mind, and I would say that the most realistic things we can do to consider that is, when I work with organizations and they're setting up their AI security frameworks, there are lots of really basic things that sound so obvious, like have a map, have a clear idea of what data is going where in which AI tool, what decisions it makes, how they all interact with each other. If you take that a level down and you think about how all of the different security gates or decisions are made within that system map, as well as things like your use policy. When you're thinking about agents, it's not really just about human use, but agent use. What can they have access to, and how, and under what circumstances? Those are the kinds of decisions you need to be making, because they impact your MCP A2A implementation. a lot of that is education. A lot of it is also really specific to your organization and the specific tools that you're interacting with. So I wouldn't necessarily get into that level with you here. You know, I'm not going to talk through how specifically you need to set up your protocol in this context with that kind of tool. I think if you think more broadly and strategically about all of those key decisions, then that is just a useful mental model to have when you're thinking about security of these protocols. The other interesting question it introduces, so I mentioned before that it's not just about, you know, human use or human permissions, but your agentic permissions. It's actually quite an interesting exercise extrapolating all of your traditional cybersecurity controls that apply to humans and organizations by adapting them for your agents as well. So if you're thinking about RBAC, so role-based access control for humans, what does that look like for an agent? How do you determine what your agents can do? Might you have more generalized agents that can, you know, do a bunch of things and use a bunch of tools and interact with lots of agents? Or might you consider having more narrow agents to reduce that attack surface and ensure the security is, you know, more locked down, but also more traceable, more easily auditable? All of that kind of stuff is actually really fun. I'm going to leave that here. Please let me know if you have any questions. MCP and A to A and other frameworks are things that come up quite a lot, so I'd be very happy to do another video on it. Let me know what more you want to hear about this topic, but let me know what else you want to hear about as well. It's really hard coming up with topics for you guys, also because a lot of the topics that I more naturally gravitate to are things where you know, I have friends who are working in at more of the policy governance layer, for example, and I know that a lot of you come on here for more technical content. So if you tell me specifically what kind of technical stuff you want to see, I'll make it happen. Anyway, I must go. It is 4:30 p.m. here in Blackpool, and it is now dark outside. I'm in the UK at the moment, and I really don't know why I'm here, because it's summer in Australia right now and I could be there. But, you know, I'm here, I'm doing the AI thing, I'm working hard, all for you. So it's dark now, and I'm doing it for you. If you haven't already, please subscribe to my channel, give me any feedback. The AI Security Fundamentals course, it's not too late to express your interest. I've had a lot more interest than I expected, which has been great. But yeah, there is still time before the applications close. And I look forward to seeing you in my next videos, in the course ideally. So have a great rest of your day, and I'll see you then.